Hi everybody. So in this video, we're going to look at the locus of a point. So as we move point P along the parabola, we'll be looking at the locus of point M. And we'll be finding the Cartesian equation for the path in which this takes. I can illustrate what I mean using GeoGebra. So if we move point P along the parabola, we're looking to find the Cartesian equation of this blue curve. Okay? This will be the equation of a locus of point M. So if we go back to our notebook, we've been told that the parabola has parametric equations at squared and 2at, and that the equation of this normal line segment is given here, and that this normal intersects the x-axis at point x, marked here. The first thing we've been asked to do is to show that this is the general coordinate of the point x. So we know at x, y equals 0. So if we substitute 0 into the equation of a normal, then we get tx will equal 2at plus at cubed. Now we can make x the subject, we'll divide both sides by t, and then these will cancel, and this will become at squared. So now we have our general x coordinate. I'll label this on a graph. And then for part B, point M is the midpoint of px. Find the coordinates of point M. So this will be the average x coordinate of p and x. So if we add these two together and then divide by 2, we'll find the mean x value. So xm will equal at squared, which is at point P, plus 2a plus at squared at point x, and then we'll divide this by 2. We'll collect the at squareds together, and then factor out the 2. And we can see that these two will cancel. So a general x value at point M will be at squared plus a. We can work out the general y coordinate of M. We know y equals 0 at point x and 2at at point P. So we'll find the average of these. So a general y point will be 2at plus the 0 divided by 2, so at. So at M, we've got the general coordinates of at squared plus a for x and at for y. So to find the Cartesian equation, we can write this t in terms of x and a, and then substitute that expression for t into y. Then we'll have one equation involving x and y, and that'll be our Cartesian equation. So if we make t the subject of this, we get x minus a over a will equal t squared. So we'll take the square root, and this will equal t. And then we'll substitute this into here. So y will equal a times the square root of x minus a over a. We can cancel out this square root by squaring every term. The square and the square root will cancel. So y squared will equal a squared times x minus a over a. We can see the square and this will cancel. So y squared will equal a lots of x minus a. We'll expand out the bracket and then take the square root of both sides. And this is what we were asked to show here. So if we go back to GeoGebra, we'll recreate the locus of M by moving point P around the parabola. We'll go to algebra, and I'll turn on our equation. That point M does move around this parabola. This is the equation we found. Okay? Well, thank you for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com.